Go. All right, hopefully that'll be fixed. Okay, so sorry about the audio initially, but anyway, today we're going to finish up on searching and sorting. Very, very briefly here, we're going to do a few more comparators in both languages, and then what we'll do is we'll do a full exercise from Advent of Code, which is a great website for review, for practice for the midterm, and of course over the break. So if you have questions, please go ahead and post to Piazza and or YouTube. We are on both. Let me go ahead and move this over. There we go. I can see you both. All right, so remember that we left off last time with making a few comparators for the student structure that we had made. In fact, we only made one, it looks like. Between those two classes, I went ahead and made a roster here of 5 dummy students so that we could actually play around with this. This is basically what you did in your lab yesterday, right? So I'm going to go, I print them out here, and now let's go ahead and sort them according to that comparator that we made. That comparator that we made was for last name and then first name, right? So we should expect, say, both of these Burks here to be first, and then me to come first, and then Tommy to come second here. And then Jimmy, John, Papa, John, and then finally Alice Buffett. She should come between all these if it's properly sorted. How do we actually invoke QSort at this point? Remember, QSort requires 4 arguments. The thing that you want to sort, which in this case is the roster, the number of elements in that roster, which I put into a variable up here, n, right? And then the size of each element in that array. Each element in that array is a student. So how many bytes does a student take? Well, size of student, okay? And then finally, the comparator that you want to use. If you want to sort it by a student by name, all you need to do is plug in this comparator, and it should work. All right, let's go ahead and make sure that it works. Student.c and demo.c, and it compiles at least. And when I run it, then here's the original order that I print out. Burke, John, Johns, and Buffett. And then finally Burke, Buffett, John, Johns. And of course the original relative ordering here is unchanged, right, because it was already in order with respect to the first name. Okay. All right, write another comparator. How else would you want to order the student object here, the student structure? We'll do one comparator, your choice. By year? Okay, by year. Remember, the way that we did year here is through an enumerated type. All right, so let's go ahead and create a comparator that sorts them by year. Now be careful here. Who should come first? Earlier years, so in other words, freshmen should come first, then a sophomore, then a junior, then a senior. This is going to work out really well because of the way that we designed this, right? Freshman, sophomore, junior, senior, right? Remember that these take on default values. This ends up being 0, 1, 2, 3, 4, or 2, 3, excuse me. Right? So because we're used an enumerated type here, we can exploit the fact that it's an integer and it's comparable. So all we need to do is, did I cut and paste it? Yep, good. Okay, students by year. And of course I need to update the documentation here. Order structures in ascending order with respect to their year. Right. Okay. So if anybody else is watching online, they can go ahead and direct them to my websites and stuff like that. We're just getting some random internet folks. Welcome. Right. Anyway, to go back. All right. All I need to do is make a comparison with the year. X year, right? If that is less than Y year, then return something negative. Right? All right. Then if it's the opposite, return something positive. If they're equal, return 0. Now remember that I told you that you shouldn't use the difference trick in general, right? Right. When we looked at these as integers, y minus x. If I did this and I had, say, 2 billion here, and then I had negative 2 billion here, they would be out of order. But the difference would be positive 4 billion. So it would give me the wrong, which would be correct mathematically, but it would overflow and give me something negative saying that they were in order, right? Do we have that same problem here with small enumerated types? There's no risk of, there's not a reasonable risk of overflow here. So what I could do is I could use the difference trick in this one instance. Tell me what order I want though. Ascending, so 0, 1, 2, 3, freshman down to senior. Is this going to give me that? Freshman minus senior, 0 minus 3 is going to give me something negative. So what order do I want? Y minus X. I had not anticipated that request, so I'm not actually printing this stuff out. What would it look like if I actually printed it out? You know, down here, I'm printing their birthday, their GPA, etc. If I were to print their year, percent %S, as a year down at the bottom here. So S year. Okay. Well, remember it's an enumerated type, so it's going to end up being a integer. Let's go ahead and see what this looks like. Actually, first, let's use it. So qsort, exact same thing as before. Let me go ahead and give myself some more room here. Printf, percent, and the line. There we go. Just so that we can see, oops, whoa. Quick key, mashing the keyboard there. Print this, and then print this at the end. There we go. And instead of using that first comparator that we made, let's go ahead and use the year. So this is a trick. Tricks are for kids in general, but this trick will work here because you're not going to have a billion enumerated types, right? You're going to have a small number of enumerated types, and the difference trick is perfectly fine in this instance. Looks like I screwed up on the toString. What did I do? Comma. Oops. Oh no. Maybe it didn't like that. Okay. Nope. Oh, is there? Where did I screw up? Oh, sorry. You're right. There we go. Thank you. All right. There we go. Run this. Now remember, who was the freshman? It was Jimmy John's, right? And it looks like, oops. This is the last one, right? Oh, so we've actually got seniors here first. So we were wrong. That's all right. X minus Y. If that's the one that you want, freshmen down to seniors in ascending order. There we go. That'll work. So there's Jimmy John first, and then the sophomore, then the junior, then the 2 seniors. The problem here is that it's printed it out as a number because that's what enumerated types are. What would be one solution to this? If it's equal to freshman, then use the freshman. If it's equal to sophomore, then use sophomore, right? What's another way I could do it? Let me go over here to the header file and create a const char star const char star year to string. I'll do it like this, right? And I'll just make it large enough for anything that I want. What if I did freshman, or is it men? Mon, I guess. Sophomore, junior, junior, and senior. What if I put them in that order? Now, freshman, which has a value of 0, what index could I use on this array? 0, right? 1, 2, 3. And what I could do down here is, what did I call it first? Cut and paste this and move it. Let's go over here. And I will use the year as an index to that thing. Right. Let's see if this works. Oh, by the way, I need to change this to a string because now that's a string. Ah, darn it. All right. Oh, I didn't set an equal sign. Duh. Equals. This should work. Oh, no, I just keep screwing up all over the place. Oh, that's not where my semicolon go. I can't program today. All right. There we go. Multiple definitions. That's because I am including it twice. That's okay. That should be just a warning. No, it's not. All right, fine. I'll go ahead and put it in the source file here. The solution to that is to use an include guard. Don't worry about what that is. We don't go over it. We don't expect it. There we go. There we go. There. Cool solution, right? Rather than if, else, if, else, if, else. I am using indices. I'm exploiting the fact that they are enumerated types that can be used as indices to an array of strings, and then just look that up. Pretty cool. Right? Other things that you want to see with respect to these? How would it look like? What would it look like if you wanted to do it by GPA? GPA is another value that's only 0 through 4, so you might be safe with the difference trick there. Let's try it. I won't do documentation anymore, but I will do GPA and GPA. Is that the order I want, by the way? Do I want, this will be in increasing order, so the low GPA is up here and then the high GPA is down here. Is that what we want? Yes, no, maybe, right? It all depends on what you want. So if you want it high to low, then you would need to go X and Y. And let's see if this works. Hopefully it doesn't work. GPA. It shouldn't work. But with such a small number of them, yep, it didn't work. Good. Why didn't it work? 4, 3.5, 3.7, 5? Is that in order? What happened? Does the difference trick work here? 3.75 minus 3.5 is what? 0.25. 0.25, what happens to that when you return it as an integer? Truncation to 0. 3.25, 3.75, whatever they were, they're the same thing. Right? Can't do that. So you hear the difference trick also doesn't work. If this, then we return something negative. Else, if y GPA is, is greater than, they're in order. If it's less than x's GPA, then we'll return something positive. Else, we'll return 0. Okay. Now let's see if this works. And, oh, okay, it's going in the opposite direction here, but that's all right. I could just go ahead and swap these around and get what we originally wanted. 4.0, 3.75, then 3.5, then 2.5, and down to 1.5. Good? One other thing I want to draw to your attention here is sorting stability. And for that, I've just got a demo over here in a web page. Right? So I'm going to go. I'm going to go ahead and refresh this. And this is not in any order. Right? We've got Castro, Rizzo, Jackson, Baez, Lake, Renteria, and Sandberg here. What I want to do is I want to sort them by their last name, first name. Let me go ahead and do that once. Right? So now you see that it is in order. Baez comes first, and then down at the end we've got Sandberg. Right? It's in order. If I hit this sorting button again, would you expect the order to change? Sort it once, sort it twice. You should get the same thing, right? Let's find out. Did I get the same thing? I got the same thing with respect to the last name, first name, but if I hit this over and over again, you see that it is fluctuating, right? Things that are equal, Javier Baez here, for example, the first and the third record there are swapping back and forth. This is what's called an unstable sorting algorithm. So if you have A, B, C, and the sorting algorithm says, oh, from my perspective, from my comparator, these are all the same, then it should not change the relative ordering of A, B, and C. If it ends up changing the relative ordering of A, B, and C, it's an unstable sorting algorithm. Why would you want a stable sorting algorithm? Let me show you one use case for that. What if I sort by GPA in ascending order, or let's go with descending order, right? Best GPA is up top. And then I sorted by year. What would your expectation be? All the freshmen would be here, but the original order would be preserved. High GPAs to low GPAs within that group. Then the sophomores, then the juniors, then the seniors. Each one of those, groups, I guess, would retain the original relative ordering of high GPA to low GPA. Unfortunately, I think that this one does, but in general, unstable sorting algorithms would not give that to you. Right? So in general, sometimes you want stable sorting algorithms. Generally, any sorting algorithm can be made stable. Some of them are, to make them stable would require a little bit more work, right? And it's all whether or not, you do need that functionality. Okay. Did it preserve everything here? It looks like it did to me, but that's only because we don't have too much data. Right? I'm sure that I could, again, if you hit the sorting button over and over again, you can see that it is definitely unstable here. That's the default JavaScript sorting algorithm. Right? Is the sorting algorithm QSort, is it stable? I have no idea. You'd have to test it out. Probably even rip open the source code and prove that it's stable. Okay. What would it look like for oldest to youngest? We're not going to do it, but what would it look like? What would your comparator look like? So you'd go to the date, right? And if the year is less, then return something negative, right? Oldest first. If they're the same, then where do you go? To the month. If the months are the same, if the months are different, then you can immediately return. If they're the same, then where do you go? The date. They were born in the same year, same month, but one person was born one day earlier, right? You'd have to look at all three of those things. That sounds complex enough that you probably want to make a comparator for dates and then hand off the dates for the student structure itself. Right? Okay, let's talk about the same thing here in Java. In Java, what we did is we created a compare student by name. We created one by a first name, last name, and then get age. So anybody with the same first name and last name would then be ordered in oldest first, but we don't have any like that. I have the exact same data here. Okay. So let's go ahead and sort things. Collections.sort. And here, if I just gave it to students, the roster, right, it's not going to be able to do this for me. Whereas with the last time we demonstrated how you can sort integers in the default natural ordering, which is going to be in ascending order, just by simply giving it a list of integers or a list of doubles or a list of strings, you explicitly have to provide a comparator here for user-defined types like students. Right? It doesn't know anything about students. You need to be providing the comparator the way to order them. Right? So in this case, I'll go ahead and go with C here. I was printing them out up here. Let's go ahead and print them out down here. I'll probably also want to print out a couple of end-line characters. Right. The function itself will give me one, and then another one will give me two, so that everything will be separated here. There's the original ordering. There's the ordering by name. So Alice is right in the middle there. Right? What sorting? Let me just do one comparison here. One comparison that I want. So again, following this nice, easy syntax up here, let's go ahead and create a comparator CMP student by age. Right? So I don't care about their first name, last name. I'm just going to go ahead and order them oldest to youngest. So comparator.comparing, comparing student age, or get age. There we go. And then sort it with respect to that comparator, print it out again. Run this, and there. That looks like it's, if I do it by age, that's going to be in ascending order. So somebody that is only 5 years old, it looks like, is going to be first, and then I put myself last. What if I wanted the reverse? You can chain this to reversed. Oldest first. And there we go. I'm at the top. And Alice is down at the bottom. Alice is definitely older than me. Alice Buffett. Warren Buffett's daughter. No? Okay, never mind. All right. So I only know that because one of my kids go to Alice Buffett Middle School. All right, so any questions on comparisons, searching, sorting? Otherwise, let's do something fun. Go ahead and get rid of this. So yeah, go ahead.
So I just had a question. So do you always have to use like binary search or a searching method if you can easily solve it with
You don't. I mean, you don't have to do anything, right? You could always do brute force. In fact, that's what this exercise is going to be about, right? So, adventofcode.com is a website that has been going on for many years. I guess this is the 7th year that we'll be in. It started back in 2015. It's an advent calendar, right? On each day, a new programming challenge is released. You can use whatever language you want because it's language agnostic. It gives you an input, typically a file, and it expects a number as output. And so inputs are different for each user. You can log into this using your GitHub account. And the Advent calendar, of course, will start on December 1st this year. It hasn't started yet. You can always go back to old years and do the exercises. Typically, the first one is kind of easy. And then there are 2 of them per day. And you earn a star for each one. The first one is kind of easy. And then but I like the way that he designs it, because if you do the first one hackishly, it makes the second one even harder to do. And you have to go back and fix your mistakes with the first one. And we'll see what I mean by that with the exercise that we're going to do. They do get progressively harder as it goes through. Somebody asked me yesterday whether or not just this class would qualify somebody to earn all 50 stars. I said, probably. Your patience would run out before your skill set runs out. It does kind of get, unless you're really, really motivated that, like for example, I didn't even bother finishing the second year here because this one right here, the day 11, it was just an arduous task that it was just going to be a whole bunch of different lines of code, and I didn't want to do that. It was like a game simulation of some sort. And so I gave up that year, but I pushed through on 2017, 2018, 2019, I don't know what happened there. 2020, of course, was the pandemic. I know. Usually what I do is I either live stream or I use these exercises to create a final exam or to as inspiration for a final exam exercise. Or I just, anytime somebody asks me, what's the best way to prepare for the final? What's the best way to keep fresh, to keep frosty with my skills over the break so I don't forget everything? Advent of Code. Right? It's kind of fun, and you'll see how fun it is here in a second. All right, let me go ahead and go to day 1 of last year. I did this last week because I was thinking of the final. I've got the idea for the final. It did not come from Advent of Code this year, so don't worry about that. But doing these exercises will really help you keep your skills fresh. It's kind of like coding kata, right? It's exercises. So I did this last week, and I really liked it because it illustrated exactly why you want to search and sort and use binary search rather than linear search for large data sets. So there's always a background story here. We'll just skip that. Basically, what you're trying to do is you're given this set of numbers, 1 to a line, and you have to find a combination of them that sums to 2020 because it was last year. Right? And for example, this first number, 1721, excuse me, and 291, add those together, and that adds up to 2020. If you multiply those numbers together, then you get this number, and that is your solution. Right? This 514579 is the solution to this one small example right here. here's my input. I'll just open it up in a new tab here. Right? There are actually 200 numbers here. Right? Pretty small. Right? So let's go ahead and try to find the two numbers in that list, or in that file, that sum to 2020. So, okay, I've got a shell here. All I did was I cut and pasted that already to a file called day01.txt. You're going to help me with this, 200. Okay. All right. So first thing I need to do is open up that file, read in line by line, and put those things into an array so I can start working with it, right? So first step would be to open up a file. Open. Say what? Okay. And I call it day01.txt. And I'm opening it up for the purposes of reading it. I'll also need a buffer here, char buffer. And I'll just make it big enough to hold any single line. Right? 100 is way more than enough. None of those lines are very, very long. Right? In fact, they're all at most 4-digit numbers. So all I would need is 4 digits, the end line character, and then the null terminating character. I could get by with 6 probably, but I'll just overestimate it. Okay. I'll also need an array, an integer array to hold all of those values. A is equal to int star malloc. And how many of them are you going to want? Well, I'll just go ahead and hard code it here to, well, not hard code it, but I'll put it into a variable here. Normally, what would you do? You'd have to go through the file, count up the number of lines, and say, okay, I need size 200 here. Or go back to hack 10 and reuse some of that code there. Right? When you do your project, code reuse. Go back to your hacks. Reuse them as much as you can, as much as possible. Make sure that they work, though, of course. All right, so size of int times n. Right? That'll create an array of that size. Now all I need to do is go through each line and read it in, convert it to an integer, and then put that integer into my array. So for int I equals 0, I is less than n, I plus plus. How do I read a line of code, or read a line from a file again? No? Forgets, right? And I'll read it into the buffer. At most 100 minus 1 characters to accommodate for the null terminating character, which it takes care of automatically. Right? Once I've got that in the buffer, how do I transform it? How do I transform it into an integer? Oh, no, sorry. A string into an integer. A to I of buffer. Okay. And then you can put it into the array. A sub I is equal to x. You could get away with this in one line if you wanted to, but I wanted to, you know, step-by-step process here. Okay. If you want to, you can go ahead and print that out and see that it works for this printf %d and the line. And I will go into exercise GCC solution for the day 1. Oops, %d, I forgot to a sub I. There we go. By the way, there are bonus points for whoever gets this. I think the first 100 people or something to submit a solution. That means you have to stay up till midnight every night throughout the entire December. I made the leaderboards once, but that's just because I stayed up randomly for one night. It was not the top 10 at all, either. But I did make it into the top 100 or whatever it was. So run that. 1778 is the last one. 2000 is the first one. That looks correct to me. Excellent. So I'm reading them in. Now, how do I find the two that sum up to my target value, which is 2020? So let's go back over to the data. Well, 2000. Okay, go through the rest of it and find the one that, when you add it to 2000, sums up to 2020. Second one, which is 50. Go through, find the next one, the one that 50 plus that one sums up to 2020. let's go ahead and do that solution first. So I'm going to go for every single pair. This one, I'm going to search all the others. The second one, I'm going to search all the others. The third one, I'm going to search all the others until I find the pair that I'm looking for. Does that sound familiar? That sounds like selection sort to me. Right? So it's, in fact, the loop is going to be exactly selection sort. I is less than n minus 1, I plus plus. For int j is equal to I plus 1, right? Because I don't want I plus I, because then 1010, 1010, that would be a value, right? And I want two distinct values. Why do I start at I plus 1? Well, if this is the ith one, I want to look at all the others. So I plus 1, I plus 2, dot, dot, dot. J is less than n, j plus plus. And now I've got my two values. Int sum is equal to a sub I plus a sub j. And if that sum is equal to 2020, or my target value here, then I will printf found. %d, and the line. And there's no reason to move on anymore. You can quit at this point if you want to, but we'll go ahead and keep it here. A sub I and a sub j. There we go. So let's go ahead and run this again, and let's see if we can get a solution out of this. 32 and 1988. Add those up. What do you get? 2020. Right? Multiply those together, and what do you get? Tell me, Wolfram Alpha. 63616. And that's what I submitted and got credit for here. Where was it? Here, right here. 63616. Right. Excellent. Now that worked because there were only 200 numbers and they were all small numbers. What I did to demonstrate why this is a terrible solution is I created a big version of day one data. It's so big that this IDE won't even allow me to open it. How big is it? Well, let's look at it first of all. Big day one. Right? So they're larger numbers because if I had chosen smaller numbers, I would have run out of 4-digit numbers really, really quick. Right? So there are many of them here. I wonder how big it is. Let's go ahead and do a word count, but only count the lines of my big file, and you'll see that there are 1 million. Right? Okay, let's go ahead and try this then. 1 million instead of 200. 1, 2, 3. And then instead of day one, it's going to be big day one. And run it. All right. How long do you think is this going to take? Well, remember what we're doing here? We're choosing pairs. How many ways are there of doing that? You calculate it. Binomial coefficients, right? N choose K, right? On hack 12. Right? If I have 1 million elements and I choose 2 of them, how many ways are there of doing that? What is that? About 500 billion? Okay. Are you done yet? Nope. Okay, 500 billion. That can't be that bad, right? What if we did, say, I don't know, how much power do you want to give my computer here? This is not my computer. This is Amazon Web Services computer sitting on some Docker instance somewhere halfway across the world, right? So how much power do you think you want to give that computer? Say that they do 1 million operations per second. 1, 2, 3. That's the number of seconds that it will take to execute. Right? Half a million seconds? Well, let's get that into time that we understand here. 60 seconds in a minute, 60 minutes in an hour. So how many hours will this take? 138 hours? All right. Do you want to sit here and do that? Nope. All right, well, we'll just put it on a faster computer. Instead of 1 million operations per second, 10 million operations per second. Is that going to help? 13 hours now. Still going to sit here for 13 hours? Even if it's 100 times as fast as we originally gave it, right? It can do 100 million operations per second. It is still going to take you almost an hour and a half of sitting here waiting. Good idea, bad idea? Bad idea. Let's rethink this. Let's go back to the data that we can actually see here. 2000. I need to find an element that when added to 2000 gives me 2020. How many elements are there that will do that for you? 2000 plus x is equal to 2020. What is x? 20. All you have to do is search through here and say, is there a 20 in there somewhere? Right? Do you need to check every single one? Nope, that ain't it, that ain't it, that ain't it, that ain't it, dot, 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 dot. What do you need to do? Binary search. If you do binary search and you ask the question, is 20 in this array? Right? Instead of doing a linear search, like selection sort is basically doing, you are getting away with an exponentially faster number of comparisons. Right? The bad part is that you have to sort it first. So let's make a comparator for integers. Remind me, what does that look like? CMP int. Does it take two integers, x and y? Nope. Does it take two integer pointers, x and y? Nope. Const void star a, const void star b. All right? And then you force them to become the integers within that function. Const int star x is equal to cast of a, right? Y equals cast of b. And now they're integers that you can actually, do things with. These are large numbers, so you do risk overflow, underflow. And so I'm not going to do the difference trick. If x is less than y, then I will simply return -1. Oops. Else if x is greater than y, then I will return +1. Else return 0. Right? Why did I put stars in front of them? X and Y are pointers. And if you've got pointers to make a comparison, you need to make them into regular old variables. And that's how you do it, dereference it. All right, so I need to quick sort this, sorry. Q sort. What do I want to sort? I want to sort the array. How many things are in the array? N of them. How many bytes does each one take? Size of int. And there's the comparator that you want to use. All right. My target is no longer 2020, by the way, because that would have been very, very small numbers. So what I did is I changed my target for this date to be 2021. About, I typed it right? Yeah, okay, 20 million something, right? Okay, let's get rid of that. Now for each number, I need to potentially find another number in that array whose sum with that number is equal to the target. So how do I get the difference? Well, int y is equal to target minus array sub, or a sub I. That's the value I'm looking for, y right there. Right? How do I find it? You said B search. How do I call B search? Exact same arguments, except now I need a key element in front. What is my key? Y. Is it going to work like that though? Man B search. I'm searching for the value stored in Y, but does it expect a regular old integer? Nope, it expects a pointer. Right? So how do I take a regular old variable and make it into a pointer? There we go. That returns a value. Int result. Now that result is either going to be successful or not successful. It's either going to find y, a value that matches y that's equal to y, or it's going to find it's not going to find anything at all. If it doesn't find it, right, there is no such y. There was no 20. All right, well, move on to the next one. Now is there 1970? Right? No. All right, move on to the next one, etc., until you find what you're looking for. So only if it's successful should I stop. If result is not equal to null, then printf found, right? %d, %d, and the line. And what are those values? A sub I, and I'll go ahead and put it in as a result here. If I compiled this, there would be a warning. %d expects an integer, right? Is result an integer? It's an integer pointer. So once again, how do I take a pointer and make it into an integer, a regular old variable? Dereference. Okay. Let's find out if this works now. Oops, target. Target. Did I screw up? It's right there. Did I misspell it? Target. There's something wrong before. Oh, way up here. Did I forget another semicolon? 28? Oh, thank you. There we go. All right, remember we estimated that it would take at least an hour and a half, maybe 140 hours, something like that. Let's find out now. Done. All right? So, an hour and a half or less than 1 second. Which one? Right? So that's why you always want to look for a searching, sorting kind of solution. You'll have to do the same thing for your project. It deals with financial data, and you have a database snapshot and another database snapshot, and you have to find anomalies between them. And if you just use naive linear search to find, here's a transaction over here, is that transaction over here? If you use naive linear search, it ain't never going to run. You've got 10 million records over here, 10 million records over here. But if you do B search, then, yep, it'll run just like this. Now, why did it report it twice? Well, because I was not going over every single pair anymore, right? I found it 432, blah, 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 and then the other one. And then when I went over to this one, I found the original as well. If you want to only report it once, well, you could go ahead and exit at that point. Once you've found something, then you're done. Right? Verify that these do, in fact, add up to 2021, 2021. I'm not lying. I had to write a significant amount of programming to randomly generate a bunch of numbers, and then I had to go through and make sure that none of them were, that there was only one pair that actually summed up to this target. So that took me maybe an hour or so to actually generate this data. And Advent of Code is not going to give you 4 megabytes of data, or whatever it ends up being. Right? All right, questions so far? Repeat in Java. So new class, Advent, finish. All right. And I've got data here. Let me go ahead and create a new file here and put that stuff in there. Day01.txt. There we go. So help me out here. How do I do file I/O in Java for the equivalent there? I'd probably want to do a scanner. S is equal to new scanner. And I want to do this on a file, so new file. And it's going to be in data day01.txt. File, import your scanner. By the way, does anybody know any shortcuts? Hopefully with when you did hack 10 for file I/O, I strongly encouraged you to RTM, read around, right? There's a one-liner that will open up a file and get everything for you. It's in the NIO library. Is it Java file or NIO read content, read file? Not to bytes, but to string. Reading and writing files using the NIO API. So you can read everything all with one big giant, with one-liner, read all lines, right? That looks familiar, right? You could have just used files.read all lines and you're done, right? And then return it. Those were meant to be one-liners that you just use something that's already built into Java. Right? If you're using those as your resubmission opportunity, you know, start reading some documentation and make your life way easier. So I'm going to go ahead and just throw this. There we go. Just to ignore it. All right, now let's go ahead and read line by, do we want to read line by line, or do we want to actually use this? This? Okay. Forget about you, Scanner. Open you up. Instead of input.txt, I'm going to have to import all this stuff. Import the NIO library, import the NIO library for paths, and import a list. Now that's a list of strings, of course. Add throws. There we go. That's a list of strings, so how do I convert that list of strings into integers? Numbers. Yep, I'm going to have to, I don't have to, but I will. I'll just iterate over it for string s in lines. I will go ahead and say numbers.add integer.parseInt s. There we go. And now I've got all of them into a one line. Right? Now, if you really want to have some fun, you can look at what's called a lambda expression. So Java lambda convert list of strings to list of integers. Integers. I'm sure that would have corrected it. Convert an array list of strings to a list of integers. Right there. Let me explain what this is doing. Right. So here's my list of numbers, right? And here's my lines, and then I need to import collectors. Once it gets compiled, should be good. There we go. So what this is doing is this is creating a stream and a map. It is taking this list, which is of course an enumerable, enumeratable, I guess you would say it. It's iterable. That's the correct word. In other words, you can create a stream. It has a collection of stuff. You can create a stream for it. And then what you can do is you can throw it through a map that will be applied to each element in that stream. That results in another stream. Right? You can collect that into a list for giving you this list of integers. This kind of programming is more functional style programming, and it was introduced in later Javas like Java 9, 10, etc. And so it's not like old school Java; it's newer Java. The way they did it is not great. It's just syntactic sugar, basically. Your code will eventually, ultimately, get compiled into something else. But it's kind of cool, right? I can do this it is a one-liner, right? I could go ahead and put this back up here and put this back up here. Right? There's that other syntax that we were looking at earlier. What is that again? That's the method selection operator. The integer class, I want to do this by the value of, right? What I was doing before was integer.parseInt. There's another function called value of that does the exact same thing. All right, now that I've got my numbers, what do? I could do that naive for loop, double for loop, but I don't want to do that. I want to do searching and sorting immediately. So, help me out. Convert this chunk of code over here to Java. First of all, sorting it. I don't use qsort. What do? Collections.sort. And since it's a built-in type, numbers, do I need to do anything special? Nope, just sort it in ascending order. It's complaining about the rest of this stuff, but we'll go ahead and get rid of it. There we go. Well, what are you complaining about? Collections, fine. Then import it. There. All right. First line of the for loop here is going to be exactly as before, but instead of n, it's going to be numbers.size. Right? I didn't store that into an integer because there was no need to. It's Java. My target will be what? Numbers dot get I, because it is a list now instead of an array. Okay. How do I do binary search? Collections dot binary search. And I want to search the numbers for what value? Y. What will that return? That returns an index. It cannot return a pointer because we don't have pointers in Java. So I don't check whether or not it's null. What do I check for? Whether it's greater than, what if I find it at zero, right? Index is greater than or equal to 0. Then I found what I'm looking for. And I can go ahead and use system.out.println and system.exit. And everything has been successfully translated, except for numbers.getI and, what was it, y. There we go. That's good enough. So let's try this again. Remember, I forget what the original solution was. It's the small file. Oh no. Darn you. Oh, yes, this is the small file, so that's not the target. What's the target? 2020. There we go. And run it. There we go. 32/1988. That was right? Okay. Excellent. So let's go ahead and go with the big number, the big list. Big day 01.txt. It's not going to let me cut and paste this, so I should just download this. Download it. I don't want to open it. I want to save it. I assure you that it is over here. I'll just drag and drop. Actually, I don't need this, and I can just do it and delete this. Drag and drop this over into the data folder. Copy it. Here, this will probably let me open it. That IDE was not forgiving, but you can see that indeed there are a million elements here, and that my local IDE has no problem opening up a 4 megabyte file. A web-based Docker instance does have a problem opening up 4 megabytes. But anyway, big day 1, and run it. Instantaneous, nearly instantaneous. So that was a direct translation using binary search. Let's do it another way. So we've talked about lists, and we briefly talked about sets and maps. When you go to your project, really think about maps. It'll really simplify your life. But what I want to do here is I want to put a copy of this into a set, and we'll understand why here in a second. Nums is equal to new hash set of integer. There we go. And let me import this stuff. And then I'm going to show you a trick here. I'm going to take numbers and put it inside the parentheses here. This is what's known as a copy constructor. So what this is doing is it's got this list of numbers over here. I'm going to create a set of numbers with the exact same entries. What's the difference between a list and a set, though? You remember? A set has no duplicates, and it is unordered. Wait a second. We just solved this by ordering things and then using binary search. I'm going to show you that you can actually do this with a different data structure. In this case, a hash set. All right? All I'm going to do is go through each element. Copy. I shouldn't have. I was being dramatic, right? By deleting everything and say, forget about this stuff. I shouldn't have been so dramatic. Numbers dot size. There's my target. Numbers of dot get I. There we go. I don't need to use binary search here at all. What I can do is ask whether or not y is in that set. And I'll tell you why this is going to be really super efficient here in a second. So nums dot contains y. So if the set contains y, then we found the element that we're looking for, and we're good to go. Right? Numbers.getI, and then we can go ahead and system.out and system.exit. This should give us the same exact result, and almost in the same exact instant, right? It was a little bit noticeable there, but not that big of a deal. So why is this efficient? This is a hash set is based on a data structure called a hash table. A hash table offers nearly instantaneous lookup of any element because it uses this magical hash function. Given this element y, it maps to an index, right? You can ask the hash set, where is this y? Is this y in this array over here? And it says, okay, well, I'm going to go ahead and put this through a hash function, take this value, it gives me an index value, and then you can jump to that index value immediately. You don't have to go through the entire array of 1 million elements to see what you're looking for. But given the element, given the hash value, that tells you exactly where it lives. It's kind of like a phone book, right? Well, they don't make phone books anymore, but how do you look somebody up? You look them up in a phone book. There they are. I can jump to their address immediately, right? And that's what a hash set is doing. Underneath the hood, it is keeping track of where everything lives through this hash function. Right? We won't get into hash tables or hash-based data structures. You will eventually, computer science 2, 3, or whatever, but it is super, super fast. Right? It's a hash set. Right? We have time. What is hashing? Like in real life. If you went to the cafeteria and asked for a hash, what would you be asking for? Do they serve hash? Not the drug or anything. Yeah, hash browns, hash potatoes, right? What is hashing? The act of cutting them up, right? And that's what it's referring to. What it's a reference to is you've got this this function that maps a large domain onto a small codomain. So the way that it works is by cutting up this large domain into small pieces and putting them over here in this codomain, right? That's what a hash function is. It just simply cuts up this big, large domain into a finite, smaller domain, or codomain, excuse me, or range, if you've ever heard that before, right? Domain maps to range, right? X-axis maps to the y-axis, domain, range. Right. All right, any questions on that? No, so I've solved it 4 different ways in 2 different languages. I think we're good as far as exercises. If you want to, you can go ahead and take a look at the part 2 here. Part 2 has you doing triples. So you have to find 3 numbers whose sum is 2020. I didn't bother doing that because I can't, somebody asked me yesterday whether or not you could, is there a mathematical trick that allows you to do that? Right? With only 2, you could easily take the difference and then you were just searching for a number. But with 3, you're taking a combination of 2 and then finding a third. So you would end up having to do that 500 billion combinations with my large data set. Finding the third, of course, would be efficient, but iterating over all 500 billion, you're back at square one with 140 hours, 14 hours, or an hour and a half, depending on how much you are, or how efficient your machine is. All right. I highly recommend that you check it out. It's fun, and especially if you're bored. But string processing as well. Given this, I think that the second day was given this list of passwords. You had to validate it with respect to this metadata over here. So it requires 1 to 3 A's. Well, it has 1, so it's valid. It requires 1 to 3 B's. It has no B's, so it's invalid. It requires 2 to 9 C's. It has 8 or 9 C's here, and so it is valid. Right? And you have to go through and you have to find out how many valid passwords there are in this list. And you can see what a puzzle looks like here. Right? So kind of fun, right? Or not? I don't know. it depends on how bored you are. It is fun, but there are other things that are maybe more fun. Right? Yeah.
And then UNL used to host like a programming competition.
We still do International Programming Contest, IPC, I think it's called. Um, I don't know what their status is. That's a good question. Come on. They do things like this.
I was
IP,
gonna say it was kind of similar to.
yeah, the International Programming Contest. I'd say that IPC stuff is a little bit harder though. If you want to practice for that, definitely look at old ones. This is a little bit more straightforward because it doesn't. I mean, sometimes it requires the good solution in order to get it done. Sometimes it's okay to have the brute force solution. You're just not going to make the the top 10 or something like that, right? I don't know. Is there sponsors leaderboard? There it is. Right. So leaderboard in 2020. Of course, I was not there at all, but yeah, it looks like a top 100 people each day, and then of course the top 100 overall people. And you have some sort of story that goes along with it each year. What? Come on, 2020, or let's just go to all of the events. I think the first one you have to get Santa's sleigh working or something. This one you had to put together a circuit board to repair the sleigh. I don't know, but once you get all of them, then it kind of animates this little thing here. And oh, it was coming up with the Naughty Nice database. That's what it was. Right. It's kind of fun. Right. I made the nice list. Yay. And these are real people I know. I think Sarah, some of them were taking my course at the time, so their names will always forever be up there. No questions? All right. Well, have a good break. And by the way, I made a post today detailing some end of the semester items, including the fact that the lab 14 has been canceled and points have been granted for it. You should use that lab for getting started on Hack 14 because you will need that for your project. Hack 14, both C and Java. You can use you can work in pairs. In fact, you're encouraged to work in pairs in the hacks. But when you go and take those hacks and use them in your project, that's when the collaboration has to stop. All right. All right. I will see. Oh yeah, go ahead.
So for the two hacks that we can resubmit, can they like be two Java ones or has to be one Java?
Anything you want. Yep. All right. I will see you after the break then. Have a good Thanksgiving break and eat some turkey or whatever.